I'm Anil Kumar, and here we have an excellent question on average rate of change. We need to sketch position time and velocity time graph from the information given below. The position function of a cheetah moving across level ground in a straight line chasing after prey is given by the equation s of t equals to t cube minus 15t squared plus 63t, where t is measured in seconds and s is measured in meters. Its motion along the distance line is displayed. So along the distance line, that's the motion which is being followed by the cheetah. From this information given, you need to sketch position time graph and velocity time graph. So you can pause the video, read the question properly, sketch, and then look into my suggestions. I'll solve this question in two parts. Now in the first part, we'll discuss how to sketch position time graph, and in the second, we will do velocity time graph. So at present, we are discussing how to sketch position time graph from the given information. Now here, the equation for displacement is s of t equals to t cubed minus 15t squared plus 63t. Now the motion along a straight line shows that there are two turning points. One is at t equals to 3, the other one is at t equals to 7. That means the distance is increasing from t0 to t3, and then the distance is decreasing from t3 to t7, and then there is a turn and the distance is further increasing. We also notice that there is some hitch midway between t equals to 3 and 7, that is at t equals to 5. Now observing all this, what we should do is to display position time graph, we just need position at different times. So let's use this equation to calculate. So we'll make table of values. That should help us to sketch this graph. Let's say this is different times, and let's find position at these different times. Critical positions for us are 0, and then 3, 5, midway between 3 and 7, 7 and 10. Once we know these positions, we can join them with a curve and sketch. It's a cubic function, so it should be a smooth curve. So let's use calculator to figure out these values. First one is t equals to 0. If I substitute 0 here, let me write down the equation clearly, which is t cubed minus 15t squared plus 63t. Now if t is 0, all the three terms will be 0. Therefore, we get 0 here. Now, for t equals to 3, let me substitute t equals to 3 and calculate. So we get 3 cubed minus 15 times 3 squared plus 63 times 3. That gives you a value of 81.00. So we can write for 3, 81. Let's substitute 5 now. So we get 5 cubed minus 15 times 5 squared plus 63 times 5, and that is equal to 65.0. Let me write 65 at this place. At 7, we'll again use the same formula. 7 cubed minus 15 times 7 squared plus 63 times 7, and this is equal to 49. For 10, we get 10 cubed minus 15 times 10 squared plus 63 times 10, that gives us 130. So we have these points. With the help of these points, we can always sketch distance time graph. So let me make the coordinate axis here, and the critical points for us, as you can see, are 0, which is 0. Then we have 3, 5, 7, 10. Let's say this is our 10, and then this will be 5. And let us say, so this is 5, let us say this is 3, and this is 7. Okay, so these are my time values. T, time is given to us, let us say in seconds, where seconds is in times and S is measured in meters. So time is in seconds, and the distance S of t is in meters, right? So that is in meters. So first point is this. Then at 3 we are getting 81, so we have to go to the maximum of 130. Let us say 100 is somewhere here, so let's go by 20s, for example, 20, 40, 60, 80, 100, 120, right? So 130 will be kind of, so that'll be around here. Okay, so that's 130. That should be a good scale to choose. At 3 it is 80, so we are taking the scale of 20 each, 20, 40, 60, 80, 100, 120, right? So at 3 it is 81, so approximately 80, so there we are. At 5 it is 65, this is 5 for us, 60 and then kind of 65. At 7, which is around here, it is 49. We can say 49 is midway between 60, somewhere there, right? So we have these points with us which can help us to sketch the graph. Now we can connect these points. You know, cubic function is a smooth curve, so we can connect these points and get our graph. So this is the turning point. So what happens here is that we can move like this, turn here, right? Now what we have in between, there is a hitch. So basically what is happening is kind of like this, coming like this and like that, and turning to n at t equals to 10. And arrow indicates that it goes on like this. So that is the displacement with time, correct? So that is our position time graph. For the given function. Now in the next video we will see how to sketch velocity time graph. What you can do is you can find the velocity function from displacement, find you can do difference quotient from here, find instantaneous rate of change, that will give you a velocity function, and that will help you to figure out the values which are essential to draw velocity time graph from this equation. You can also have a rough idea from here. Velocity is going to be 0 at these turning points, right? So that means at t equals to 3 and at t equals to 7, the velocity is going to be 0. It is going to be positive for a period from 0 to 3, negative from 3 to 7, and then again positive from 7 onwards. And since this is cubic function, velocity will be a parabola. So we are expecting a graph which will be kind of, let me sketch it approximately here, and then we'll do a better job in the next video. So basically, well, we'll not worry about the units at present, right? So this should be at 3, and then at 7, since there is a turning point, it will go kind of like this. So that will be our velocity time graph, right? This will be v of t. We will sketch it in the next video. I hope that makes things very clear. Thank you and all the best.